Okay, so let's try lev of x, because Levi made this up. So I would like to just graph this, right? And so my function is minus 7 times the quantity of 1/3 x minus 4 all cubed plus e to the pi. It should be noted that it is a relatively interesting question whether or not you could demonstrate if e to the pi is a fraction or not.
E to the pi is a whole number. It is. No, they're both irrational numbers, and they.
Okay, so that is a cool thing. It is not true that if you take an irrational number to an irrational power, you always get an irrational number.
But in this case, you do.
It is known for sure that there exist pairs of irrational numbers that you do one to the other power and you get a rational number back. I can show you that proof if you want.
Is this one of those cases?
Sounds good.
I don't know.
My calculator says 23.1406.
Ah.
Okay, so at the very least, it's not a whole number. Ha! Oh, except that your calculator is working with rounded versions of both e and pi, right?
Wow.
Okay, so that's definitely one of those really squiggly squiggles. Okay, but let's figure this out.
Cool.
Because for right now, right, this is just a number that's like give or take 20, right?
What did you say it was?
23.
23.
Okay, so this is going to be like a vertical,
Shift upwards of 23.
yeah, this is going to be like a shift up by give or take 23.
Okay.
Right.
Found it.
So if you bubble diagram this thing out, I'm starting with x first. What's your first action here?
Multiply by 1/3.
Multiply by a third. Okay, so now I'm at 1/3 x. What's your next action?
Subtract 4.
Subtract 4, so now I'm at 1/3 x minus 4. What's your next action? Cube it. So now I'm at 1/3 x minus 4 cubed. What's your next thing? So close.
Multiply by 7.
Multiply by 7 or negative 1,
Mm.
right? Multiplication is commutative, so that it doesn't matter which order these two things happen in, but I do want you to think of them as being two things. Okay? So you multiply by 7, so you got 7 times stuff cubed. And then you multiply by negative 1. Okay, so now you're at negative 7 stuff cubed. And then you
Add e to the pi.
add e to the pi. And then you're at the end. Okay? So, which of these things is the rule I know about?
Cube.
Cubing. I know how to draw cubing. What does cubing look like?
It looks like squaring, except a lot steeper.
What did you say? It looks like straight except a lot steeper.
No, it looks like squaring, except a lot steeper.
No.
No.
Yeah, it goes like whoop-de-doo, right? It's a whoopty.
Oh.
Yeah, it's not an exponential, it's polynomial.
It reminds me of tangent.
It looks like one of the bits of tangent. I would prefer if we thought of tangent as looking a bit like x cubed rather than x cubed looking a bit like tangent, but whatever. Like, sure, it looks like one of those bits. The difference is this thing doesn't have any vertical asymptotes. So all good with this? Why does it go down on this side?
Negative number on it comes out.
Yeah.
You put negative input, it comes out.
Yeah, negative input gives you a negative output. Easy peasy, right? This thing is even or odd.
That thing's odd.
That thing's odd. Specifically, it's a monomial with an odd power, right? Which is where that word odd comes from. Okay, so I have my cubing, right? Now to figure out what this looks like, I want to list out what all my shifts are,
All right.
or all my kind of graph mods, right? So what's your minus 4 as a graph mod, dude?
Right.
Forward.
That's an x-land, so it's a right shift by 4. What's
I
that?
like accent.
I don't like it.
Don't like what?
Excellent.
X-land. Oh, because it's backwards?
Yeah.
Yeah, nobody likes x-land.
Do you like Australia?
Wait, is it really like? Is it backwards like this in this chapter? Like what we're doing in this chapter?
No, no, x shifts are always backwards.
Okay.
Xland's not always backwards, just here.
Horizontal stretch.
So this is a horizontal strip. Right, it was definitely horizontal because it lives in Xland, and then it's a stretch because it's multiplication by a number smaller than 1, and frickin' Xland is backwards, so that's a stretch rather than a compression. Okay, how about over here? In Y-land, you've got multiply by 7, so that's a vertical stretch. Then also in Y-land, you have a multiply by -1, which is a
Flip Y.
vertical flip, or a flip over the x-axis. And then your plus e to the pi is a
It's a shift
Shift up.
it's a vertical shift up by
Like 23.
e to the pi. Right? It's just like, take that whole thing and scoot it up e to the pi, whatever number that is.
Easy.
Yeah, I mean,
Pi. Easy pi. Oh.
no. Not in my classroom. Okay, so what do you do first with your, so you've got your little whoopty, right?
X first.
So you go backwards through the X.
Yep, so you go backwards through the x's. So you need to go right 4, first things first. So you go right 4, and you get something like this. Oops, a little bit steeper, maybe. Where's that happening?
At point 4, 0.
Yeah, so that's the point at 4, 0, right? Which is where the kind of middle of the whoopty is.
Yeah.
Where the x-intercept of the whoopty, right?
Uh-huh.
So horizontal stretch by a factor of 3.
Uh-huh.
So that goes to, yeah, so now it's going to intersect at 12, and it's going to be stretched out this way, right? Oops. Bad concavity.
Bad.
So that got a little kind of wider, right? Okay, then what?
Then you go
So this was
forward.
maybe picture 1, picture 2.
Then you go forward through Y.
Then you take that picture over here and trot it through the Y's.
Yeah.
So a vertical stretch. Thankfully, that's going to look exactly the same as this because I don't label my y-axis, right? But if I did label my y-axis, if I said like, okay, this is 1, now over here, I would draw that same picture, but the 1 will be 7.
Drawn scale.
Totally to scale,
Right.
right? This is just a sketch, right? If I wanted a really, really good picture, I wouldn't be asking you guys. I'd be asking your calculator,
Yeah, fair enough.
right?
Fair enough, yeah.
Like what I want is for you guys to understand why that picture's happening, so that if you accidentally type the wrong thing in the calculator, you'll notice.
Right.
So I got this. I went vertical stretch by 7. Then I need a
Flippity-doo.
vertical flip, which is easiest to do just on the same picture. Right, so this was picture number trace. Picture number quattro is going to be right here in black. So that's my vertical flip,
Ooh. I
right?
need to raise it
And then we need to shift it up
23.
23 units,
So
23-ish units. Right, so to get my final picture, I go like this. X-axis, right? This thing. I kind of dorked that because it's supposed to be flat in there. This dot, right, the spot where it's flat,
moves directly above the 12.
is at 12 over and
23.
It's e to the
E to the
pi.
pi.
too.
and e to the pi up.
Oh.
Right? And then if I wanted one other point on there, maybe I could track down one more point, right?
What used to be our 1, 1.
Yeah, so if I track 1, 1 through, right, like here's 1, 1. If I track 1, 1 through, in here I shifted right 4 units, so that went to, I shifted right 4 units. So it was at 1, 1. What's right 4 units from 1, 1?
1, 5.
5, 1. 1, 5 is 4 units.
Yeah.
Okay, then you need to horizontally stretch by a factor of 3, right?
Mm-hmm.
So is that changing an x thing or a y thing?
Changing that.
It's changing an x thing. So now instead of that dot being at 5, 1, it's at
15.
nice, 15, 1. And then I trot that over here, and I do my vertical stretch by 7. And now it's at 15,
7.
7 instead of 15, 1. And then I flipped it over.
So now you make the y value negative.
So it's down here, it's 15 comma negative 7. And then my final thing was to shift it up by e to the pi, right? So that dot right here should be at 15 comma
Negative 7 plus
e to the pi minus 7. Because of course you can subtract, right? So you do. Cool? You guys with that?
So is the 12 e to the pi not right?
So the 12 e to the pi is right. That's where this guy went,
Oh, okay.
right? That's, yeah. So if I had another color, I could do this. I could say there's a pink dot at this kind of interesting spot, which is not really a vertex, but
Is vertex considered when like when it's like both sides are doing the same?
yeah, vertex is where it turns around.
So is the origin what it's actually called then?
This guy?
Yeah. What is
Yeah, so that thing's actually a saddle.
it? A saddle?
Uh-huh. Like on a horse.
It's like where the whole thing rests, you know?
It's a
Only for
so it's a flat spot where you can go either up or down.
And that's only for x to the third? X to
No, that's a general thing. That's any spot on a graph where you could go from it, you could go either up in one direction or down in another, but it's flat.
Like in tangent too.
Yeah, so in tangent too. The origin in tangent is also a saddle. It makes more sense in 3 dimensions. Don't worry, I'll draw it later. We're going to talk about that later, not right now. But this guy, right, 0, 0 went to 12 comma e to the pi, and 1, 1 became 15 comma e to the pi minus 7. That's cool, that? Okay, these are luckily the 2 examples I've given you are worse than anything in the book. So do the homework from this section, it's not so bad.